Welcome to this presentation. This video is all about thermal control and TTC system. First, let us have a look into thermal control. Satellites are subject to large thermal gradients receiving the sun's radiation on one side while the other side faces into space. In addition, thermal radiation from the Earth's and the Earth's albedo, which is the fraction of the radiation falling on Earth which is reflected, can be significant for low altitude and Earth orbiting satellites, although it is negligible for geostationary satellites. Equipment in the satellites also generates heat which has to be removed. The most important consideration is that the satellite equipment should operate as nearly as possible in a stable and temperature environment. Various steps are taken to achieve this and temperature control. For example, the thermal blankets or shields can be used to provide insulation. Radiation mirrors are often used to remove the heat from the communication payload. The mirrored thermal radiator for the hugest HS-376 satellite is very huge, and it is like cylindrical shape, and these mirrored drums surround the communication equipment cells in each case and provide radiation paths for the generated heat to escape into the surrounding space. One advantage of spinning the satellites compared with the body stabilized is that the spinning body provides an averaging of the temperature extremes experienced from solar flux and the cold background of the D space. In order to maintain constant temperature conditions, heaters may be switched on, usually on command from ground, to make up for the heat reduction which occurs when the transponders are switched off. The Intelsat 6 satellite used heaters to maintain propulsion thrusters and line temperature. Now, let us see about TT and C subsystem, that is telemetry, tracking and command subsystem. The TTC system is present in both satellite and earth station. TTC system is very much necessary for any communication satellite in order to operate it successfully. It is the responsibility of the satellite operator in order to control the satellite in its lifetime after placing it in the proper orbit. The TTC subsystem performs several routine functions aboard the spacecraft. The telemetering function could be interpreted as measurement at a distance. Specifically, it refers to the overall operation of generating the electrical signal proportional to the quantity being measured and encoding and transmitting this to a distant station, which for the satellite is one of the earth stations. Data which are transmitted as telemetry signals include altitude information such as that obtained from the sun and earth sensors. Environmental information such as the magnetic field intensity and direction, the frequency of the meteorite impact, and so on. This on spacecraft information such as temperatures, power supply voltages, and stored fuel pressures. So the TTC subsystem is divided into the following three parts, and one is telemetry and monitoring system, second one is tracking subsystem, and the third one is commanding subsystem. First, let us see about the telemetry system. The telemetry system contains the data which are transmitted as a telemetry signals include the following important four informations. One is attitude information, and the second one is environmental information, and the frequency of meteorite impact, and spacecraft information. Attitude informations are like which are obtained from the sun and earth sensors. Environmental informations are like magnetic field intensity and direction. Spacecraft informations are temperature, power supply voltages, and stored fuel pressures. Certain frequencies have been designed by international agreement for satellite telemetry transmissions. During the transmission, transfer, and orbit phases of the satellite launch, a special channel is used along with the omnidirectional antenna. Once the satellite is on station, one of the normal communication transponders may be used along with its directional antennas unless some emergencies arises which makes it necessary to switch back to it the special channel used for transfer orbit. And now the next part of it is a tracking system. Tracking of the satellite is accomplished by having the satellite transmit beacons which are received at the TT and Earth station. Tracking is obviously important during the transfer and drift orbital phases of the satellite launch. Once it is on station, the position of the geostationary satellite will tend to be shifted as a result of the various disturbing forces, and therefore it is necessary to be able to track the satellite's movement and send correction signals as required. Tracking beacons may be transmitted in the telemetry channel or by pilot carriers at frequencies in one of the main communication channels or by special tracking antennas. Satellite range from the ground station is also required from time to time, and this can be determined by measurement of the propagation delay of the signals, especially transmitted for ranging purposes. And the third part is the command subsystem. The telemetry and command may be thought of as complementary functions. The telemetry subsystems transmits information about the satellite to the Earth station, while the command subsystem receives the command signals from the Earth station, often in response to the telemetered informations. The command system demodulates and, if necessary, decodes the command signals and routes these into the appropriate equipment needed to execute the necessary action. Thus, the attitude changes may be made. Communication transponder switched in and out of circuits, antennas are redirected, and the station keeping maneuvers carried out on command. So these are the command subsystem, these are the operations which the command subsystem does. It is clearly important to prevent the unauthorized commands from being received and decoded, and for this reason only the command signals are often encrypted. Telemetry and command may be thought of as complementary functions. The telemetry subsystem transmits information about the satellite to the Earth station, while the command system receives the command signals from the Earth station, often in response to the telemetry informations. And the encrypt is a word derived from the Greek word kryption, meaning to hide, and represents the process of concealing the command signals in a secure code. This differs from the normal process of encoding, which converts the characters into the command signals into a code suitable for transmission. Tracking of the satellite is accomplished by having the satellite transmit beacon signals which are received at the TTC Earth stations. Tracking is obviously important during the transfer and drift of the orbital phases of the satellite launch. Once it is on station, the position of the geostationary satellites will tend to be shifted as a result of the various disturbing forces. Therefore, it is necessary to be able to track the satellite's movement and send correction signals as required. Tracking beacons may be transmitted in the telemetric signals or by pilot carriers at frequencies in one of the main communication channels or by special tracking antennas. Satellites range from the ground station is also required from time to time. This can be determined by measurement of the propagation delay of the signals, especially transmitted for the ranging purpose. So it is clear that the telemetry, tracking and command functions are complex operations which require special ground facilities in addition to the TTC subsystems aboard the satellites. So this diagram shows the block diagram of TTC facilities used by the Canadian satellites. So here these are the main components of the systems are analysis center, satellite control center and computer center, which transmit and receive signals from data communication and reduction facility, and the voice and data links will be transmitted to TTAC station and TTAC station 2, which may transfer the signals to the satellite via some ranging commands and telemetry, and the signals from the satellite may be received by another telecast stations, and the ranging data can be retransferred to the TTAC system and the station, and that station will again send signals to send voice and data signals to the analysis center, satellite control center, and computer center. Thank you.